Hello students, let us continue with the discussion. Our next topic is Hess's law of constant heat summation. Definition I request you to take down from the textbook. Now let us try to understand the law. The law has been given by Hess and it is called constant heat summation. Now what do we understand by this? If we carry out a process in one step, say from A we convert it to D in one step. Now during this process, suppose we measure the heat change. Let it be considered to be delta H1. Now it may be possible that instead of carrying out the process at one go, we split it into number of steps. Suppose we first convert A to B, then convert B to C, and finally convert C to D. Now during each process of conversion, some heat change will be involved. Suppose A is first converted to B with a heat change of delta H2, that is the enthalpy change. From B to C, enthalpy change is delta H3. Then C to D, enthalpy change is delta H4. Now, according to Hess's law, what we can write? Delta H1 is sum total of delta H2, delta H3 and delta H4. So we can understand what could be the definition of the law. If a reaction occurs in one step or in number of steps, the total heat change will be same. Let us try to understand with the help of an example. We all know when carbon burns in sufficient oxygen, it gives us carbon dioxide. Let us assume that during this course of change, the heat change is delta H1. Now it may happen that the carbon at first go doesn't get converted to carbon dioxide. If we have insufficient supply of oxygen, it might get converted to carbon monoxide first, and during the process the heat change is delta H2. Now we convert carbon monoxide to carbon dioxide with more supply of oxygen, then the heat change is delta H3. Then according to Hess's law, what we can write? Delta H1 should be equal to sum total of delta H2 plus delta H3. That means out of three factors here, if I know any two, the third one can be calculated. So that is the gist of Hess's law of constant heat summation. Now let us move to the second part of thermodynamics, that is called spontaneity. You have noticed that if you look at your surroundings, there are certain processes which occur on their own and there are certain processes which cannot be reversed spontaneously. Say for example, if we leave some water on an open container, after few days, depending on the quantity of water, it will evaporate. When you wash your clothes or wipe your floor, you can see it gets dried eventually. That means it is conversion of liquid water to water vapor. So the process is spontaneous. If you leave some ice at room temperature, after some time you will find that the ice got melted, which is occurring on its own. But can I expect that the water will freeze to ice on its own if I leave it in the room? Not in Shillong or not. But if I am in Himalayas, then definitely we expect that the water in the liquid state can get converted to ice. So what is the factor which decides spontaneity? Let us talk in terms of enthalpy first. One thing you have to remember that any process which is occurring on their own, they are expected to attain stability. If the system attains stability, then automatically the process will occur. Now if I consider that I have to carry out a conversion where a reactant is turning to product. Now let us consider the enthalpy of the reactant is quite high at this level. This is an energy graph. This is the enthalpy, the y-axis, and x-axis we measured the reaction coordinate. That means with the passage of time, what is the change taking place. Now if the product is forming which is more stable, therefore the enthalpy of the product will be less. So HP will be less than HR. Where does the excess energy go? As you know, energy can neither be created nor destroyed. This extra energy will go to the surrounding, and we call such processes to be exothermic process. So in that way, all exothermic processes should have been spontaneous. But let me tell you, when solid ice changes to liquid, it is endothermic. Liquid water changes to gas, that is also endothermic. However, gas converting to liquid is exothermic in nature, and liquid turning to solid is also exothermic in nature. So, if all exothermic processes are spontaneous, then water should have been freezing at room temperature, but that doesn't happen. That means enthalpy is not the only criteria which will decide spontaneity. However, if I leave liquid water at room temperature, and if I leave it, say, we can take the example of drying of wet clothes. So, liquid water is getting converted to water vapor. That means water from liquid state is getting converted to water in the gaseous state. That is supposed to be an endothermic process, but it is very much happening spontaneously. So, how do you account for it? Here we have drawn the graph for endothermic processes. During an endothermic process, the enthalpy of the reactant is lower than the enthalpy of the product. Now, if enthalpy of product is high, that means the system has attained more energy, and thermodynamically the process should not be spontaneous because the system is becoming unstable. Then how do we justify these changes? Now let us take an example. To understand this, actually we need to introduce another thermodynamic parameter, which is called entropy. By entropy we mean degree of randomness. Now you can understand, when you are sitting in the class in presence of your teacher, all of you are sitting in a proper manner. Okay, think about Sakalita's class. So what is your status? Your pin drop silence. Everybody is in the attention position. Okay, but when there is no teacher, then what you do? You start talking, you start moving from one place to the other. That means there is no order in the system, and it is a complete chaosness. If the teacher takes long to come to the class, it's a complete state of chaosness. Is anybody telling you to do this? Nobody is telling you to do this, but it is happening on its own. So this chaotic process is a spontaneous process. So this degree of randomness has been defined in terms of thermodynamics by a term called entropy, designated by the symbol S. If we assume that S1 is the initial entropy of a system, that means before starting the randomness, and S2 is the final entropy of a system, then delta S is S2 minus S1, that is change in entropy. If S2 is more than S1, so you can understand the whole term will be positive. That means positive entropy is a spontaneous process. However, if S2 is less than S1, then definitely S2 minus S1 will be negative, which is unfavorable in terms of entropy. You can understand, when your S2 becomes more than S1 when the teacher enters. It is the presence of teacher which make you sit in proper position in proper order. So it is a forceful impact, not a spontaneous impact. All right. So to decide any process to be spontaneous or not, we have to think about two factors. One is enthalpy, another is entropy. So remember, sorry, delta H, which is negative, that means exothermic process, is favorable condition, and delta S should be positive for a process to be for a process to be spontaneous, that is a favorable condition. If any of the two is not met, then the process will be decided by another factor that is called temperature. So when freezing of water is a non-spontaneous process here, the same process becomes favorable when you go to upper altitude or at very cold places. So you can understand the third factor is temperature, which decides spontaneity. So combining three factors, delta H, delta S and temperature, we have the third thermodynamic parameter that is called gives free energy, delta G. Okay, and it is given by H minus Ts. By free energy we mean the useful work which can be done during a process. So delta G equal to delta H minus T delta S, or delta G naught equal to delta H naught minus T delta S naught can be asked to derive. So derivation is quite simple. Let G1 is initial gives free energy, G2 is final gives free energy at temperature T. Let H1 is the initial enthalpy, H2 be the final enthalpy, S1 is the initial entropy, S2 is the final entropy. Then applying this equation G equal to H minus Ts for each step, initial and final, we may write G1 equal to H1 minus Ts1 and G2 equal to H2 minus Ts2. Now when we subtract equation 1 from equation 2, what do we get? We get G2 minus G1 equal to H2 minus Ts2 minus H1 minus Ts1. So G2 minus G1 becomes delta G, and H2, if I take from both the sides, H2 minus H1 becomes delta H, and if I take S to be positive, then it becomes S2 minus S1. Okay, we take the minus T common, so S2 becomes positive. So ultimately we derive the formula delta G equal to delta H minus T delta S. Now delta G is the only factor by which we can at one go say whether a process is going to be spontaneous or not. How to know that? A process to be spontaneous, delta G has to be less than 0. Okay. If delta G is equal to 0, that means the state has attained equilibrium. If delta G is more than 0, the process is always going to be non-spontaneous at any temperature. So, look for the definition of delta G in the textbook, or you can try to find out from any other reference book also. Now there is a relationship between free energy change, that is delta G, and equilibrium constant K. Since you have not done equilibrium as yet, I will try to give you a brief introduction about equilibrium, then it will be easy for you to follow. Let us consider a process A plus B reversible C plus D. This reversible sign means the system has attained equilibrium. That means as much amount of A plus B giving you C plus D, after a certain period of time when the system attains equilibrium, C plus D will give you back A plus B. Now this equilibrium can be expressed in the form of an equilibrium constant by applying a law called law of mass action, which we will be doing in the chapter equilibrium. So how do you calculate value of K? Value of K is found to be concentration of C into concentration of D divided by concentration of A into concentration of B. When we write A in square bracket, it means concentration, usually in molarity. Now we can have a look here. Since K is a ratio of concentration terms, if C and D concentration is more than A and B, you can understand the value of K is going to be greater than 1. Now concentration of C and D is more than A plus B means mode of product is forming. That means the process is going to be spontaneous. And if the concentration of C and D is less than concentration of A and B, then the value of K will be less than 1. That means the process is not thermodynamically that feasible. So you can understand This value of k help us to understand spontaneity and also should have a relationship with Gibbs free energy. So it has been found that this derivation is not there in your syllabus, just you need to know for the time being. Delta G equal to delta G naught plus RT ln k. This ln means log base E, we call it natural log. Okay, and the log which we calculate normally is log base 10. So when the system is at equilibrium, as just now we have written, the value of delta G should be 0. Now what is the difference between delta G and delta G naught? Delta G is Gibbs free energy at any situation, and delta G naught is Gibbs free energy change under standard conditions. Now if delta G is equal to 0 in this particular equation, then delta G naught plus RT ln k equal to 0. So delta G equal to minus RT ln k. Now for practical applications, we don't calculate ln, we convert ln to log. And what is the conversion factor from ln to log? You have to multiply by minus 2.303. Sorry, minus sign is already there. The conversion factor is 2.303. So you can see here I have written in terms of ln, and here I have written in terms of log when I have multiplied by 2.303. So you can see delta G is coming to be negative, then the process is spontaneous if the value of k is positive. This is positive, this is negative, so multiplication of positive and negative gives you negative. So a process to be spontaneous, k should be positive and delta G should be negative. If k becomes negative, that means the process becomes non-spontaneous, because log k will become a negative value, and negative makes it positive. That means delta G becomes positive, which represents the process is non-spontaneous. Okay. Now we move to a table which was asked in AMBOS 2020. So you need to understand this. We tried to make a table by considering all possible combinations of delta H, delta S and delta G. You see, if in any process delta H is negative, which is a favorable condition, that means it is a exothermic process. Delta S is positive, that means entropy is increasing, that is also favorable condition. Now if I fit all these values in the equation, delta G equal to delta H minus T delta S, then what happens to the sign of delta G? This is negative, this is positive, so sum total of two negative numbers become negative, so delta G will be negative at all temperature. It doesn't depend on temperature at all, because both are favorable conditions. However, in some situation, one of the factors may not become favorable. You see delta H, second situation where delta H is negative, but delta S is also negative, which is not favorable. In that case, what happens to the formula? Delta G equal to delta H minus T delta S. So you can see here delta H is negative, delta S is also negative. So negative and negative makes it positive. Now sum total of a negative and a positive number will be what? That depends on which value is higher. If delta H value is higher than T delta S, then the value will be negative. Now delta H and delta S is not in our hand. What is in our hand is T. Now how can I make this factor lower than this factor? If T is small, so you can see here delta G will be negative only at low temperature. The example is freezing of ice, freezing of water, that is formation of ice, or condensation of water also you can say. I don't know how many of you have noticed in Shillong, especially during winter, early morning when ice starts forming, you can feel that the surrounding becomes warm, and early morning when the ice tend to melt, it becomes an endothermic process and the surrounding becomes very cold, and that time you don't feel like leaving your bed. Another situation when delta H is negative, that is a favorable condition, and delta S is negative, then what happens to delta G? We have already discussed this. Delta G equal to delta H minus T delta S. Now, if your T delta S value is higher, because delta S is minus, so minus and minus will make it plus, and delta H is negative, then sum total of this will be positive or negative. If T delta S is greater than delta H, then the sign of the delta G become positive. And how the sign of delta G becomes positive? The sign of delta G becomes positive, meaning the process is non-spontaneous. That means exothermic processes, if they are not favored by entropy, then the process become non-spontaneous at high temperature. The same example we can take. You can understand when water turns to ice, it is an exothermic process, and water turning to ice, that is occurring by decrease in entropy, because in liquid state molecules are at random motion, but when ice is forming in the solid state, the molecules of water, they occupy specific positions, they are not allowed to move, so entropy decreases. So can you expect ice to form at high temperature? It will never happen. Next situation let us take. When delta H is positive, that is it is endothermic process, and delta S is also positive, that is favorable, that is occurring by increase in entropy. Then what happens to sign of delta G? Delta G we know is delta H minus T delta S. So what is happening to the sign of delta G? Delta H is positive, T delta S is also positive. So here what happens? Sorry, not T delta S is positive, only delta S is positive. So this factor, if this factor is high, T delta S is high, then the process is becoming spontaneous. And how can you make T delta S high? If the temperature is high. So please remember, endothermic processes are favorable at high temperature. When does your clothes dry easily? At low temperature or high temperature? You see, drying of clothes, that means water turning from liquid to gas, is an endothermic process, and the molecular motion increases from liquid state in the gaseous state. Definitely the molecules are at more random motion. So delta S is positive. So melting of ice, evaporation of water, they are all favorable at high temperature. On the other hand, if T is low, then delta G sign will become positive and the process will become non-spontaneous. Now, if delta H is positive and delta S is negative, both are unfavorable, then the delta G sign will be always negative, always positive. You see, delta G equal to delta H minus T of minus delta S. So what will happen? Minus and minus will make it plus, and sum total of two positive numbers will be always positive. That means such a process will never occur in nature on its own, and we call them a non-spontaneous process at all temperature. Usually this table is never asked before, only in 2020 we found this question has been asked. So please try to understand this table. This is just by algebraic addition and subtraction. Let us work out one numerical from your textbook. Calculate delta G naught for the reaction 3/2 oxygen converted to ozone at 298 Kelvin if Kp value is 2.47 into 10 to the power minus 29. Now Kp means when you are measuring equilibrium constant K in terms of pressure. Instead of concentration, you are using pressure term. Now let us check. The formula remains same, delta G naught equal to minus 2.303 RT log Kp. Now Kp value is given to you. Temperature is also given to you. R value you have to choose properly in proper unit. So since we are discussing about energy, it will be in joules per mole. So it will be 8.314 joules per Kelvin per mole. And when you put the values, what do we get? You are getting the delta G value to be positive. You see 298 Kelvin is nothing but 25 degrees Celsius. That is our room temperature. Does oxygen get converted to ozone at room temperature? Have you ever seen? In that case, though, our atmosphere should have been filled with ozone only, not with oxygen. So it is experimentally proven why oxygen doesn't turn to ozone, because you see, after putting all the values, the delta G value is coming to be positive. Hence, it is a non-spontaneous process.